Alright, this is podcast number 3, and today we're going to be covering a chapter review over pretty much everything we've done so far this year. So here we go. First thing we're going to cover is the 4 states of matter. So we have solids, liquids, gas, and plasma. And the easiest way to go about remembering this is that in a container, solids are going to stay in one spot and have a definite volume and definite boundaries. Now, a liquid, on the other hand, when put into a container, is going to fill its container. And the molecules are going to be evenly dispersed throughout where the liquid is in the container. And a gas is going to fill the entire container, and its molecules are going to be spread throughout the entire thing, whizzing about in completely random directions. And plasma is a super high energy form of matter that can only really be found in space, like in our sun and other high energy forms such as that. Alright, moving on, we're going to go for chemical versus physical change. So what I have is 3 examples. Our first one's going to be adding salt to water, which you've done in class before. And this is actually going to be a physical change, because once you add salt to water and mix it around, even though it looks like the salt's no longer in there, the salt particles are still in the water, and you can actually still get them out if you evaporate off the water. So you can get the salt back, which makes it a physical change. The next one is cutting a piece of paper. This one is also going to be a physical change, because you're simply altering how it looks. You're not changing anything about the paper. You can still tape back the piece of paper to get the piece of paper back out of the process. And the third one is baking cookie dough. And this is a chemical change, because you are undergoing a process that is an irreversible process. Once you bake the cookies, there is no way that you're going to be able to get the cookie dough back out of the cookies, because baking is an irreversible chemical process. So that's a basic overview of chemical versus physical change. And also on your review sheet for your test, it says that you have to learn about the Bunsen burner. So we have a Bunsen burner. So right here we have the gas hose, and this is going to be hooked up to the gas knob that's on your table. Stand, obviously. This little knob down here, this is going to control the gas flow, which is going to make your flame higher or lower. This whole shaft here controls the oxygen airflow, because there's holes right down here at the bottom. So you turn it counterclockwise, it's going to open it up and allow more oxygen to fuel your flame, and closing it, less oxygen, less flame. And what you're going to want to do is, when you're messing with these, is to get 2 blue cones so that you can actually hear it coming off. And that is basically it about the Bunsen burner. So, one last thing we're going to cover here is structure of atoms. And you've all seen this chart before, and we're going to go over it a little more again. So say you have silver here. The atomic number is going to be found on your periodic table, and it's actually the number listed at the top. That's going to be 47. The atomic mass is found right underneath that. Is found at the bottom of the element, actually, and that is 107.9. Alright, the atomic number is always going to be the amount of protons, and the neutrons is going to be the atomic number, which is the rounded number of this, minus your protons. So for silver, that is going to be 61. And since there's no charge on silver over here, the number of electrons is going to be the same as the number of protons, 47. Same thing with potassium here. Atomic number is 19, which means the protons is 19. Atomic weight 39.10, and that makes the neutrons 20 neutrons. And since there's no charge, the electrons is the same as the protons, 19. And hydrogen, down here, atomic number is 1, atomic mass is 1 again. There's 1 proton, and there's actually 0 neutrons in hydrogen, and there's 1 electron, I mean. Alright, that's pretty much a basic overview of what you've learned so far in chemistry. Yeah.